A windfall of evidence.
That Mars is a water planet. Yes, check. Mars is a planet with energy systems incontrovertible. Then you add to that, we now have gases.
That could point to one shocking verdict. If you were a betting man, would you put money on it that this is life?
I would definitely put money on it that it's life.
Hi, I'm Josh Zepps. Welcome to Life on Mars. It's a Brink special report in which we're going to tackle one of the biggest questions of them all. Are we alone? Or is it the case that right next door to our planet is a world that is also inhabited by living creatures? That is a question that belonged to the world of science fiction until not that long ago. But the past 15 years has witnessed a string of remarkable discoveries on Mars. And as the evidence from these breakthroughs has piled up, more and more scientists are tantalizingly close to saying what was once pretty unthinkable, that there really is life on Mars.
Ladies and gentlemen, there's something happening on Mars.
On January 15th, 2009, NASA scientists announced they'd found plumes of methane in the Martian atmosphere. It's a gas which, at least on Earth, usually indicates life.
90% of the methane that is produced on Earth is being produced by biology. So to see this gas with a very short lifetime on Mars could mean biology.
So does this mean it's proof that there's life on Mars?
Methane on Mars is kind of a magical, mystical discovery because it's one of the first clear-cut indications that there's an active Mars that could, with a capital C, relate to life beyond Earth. We may never be able to tell that Mars did not have life, but the possibilities today are we will be able to tell that it did or that it does. That's exciting.
On Earth, methane gas is produced in massive quantities by decaying plant life and by the emissions of animals, like cows, sheep, goats, and even, yep, us humans. And that's the way it could work on Mars too. Microbes living deep beneath the Martian surface might be emitting the methane that we're now seeing.
We have evidence that we need to think about in terms of the possibilities of life on Mars.
The methane on Mars was discovered using 3 powerful telescopes on Earth that looked at 90% of the Martian surface over 3 Martian years. That's 7 Earth years. And it was found in 3 specific areas just to the north of the Martian equator. Scientists say the methane seems to have been released recently. The gas just wouldn't look like this if it had always been there. It looks like something is emitting it.
When you make a discovery like this that could link to the kind of life processes we know and love here on Earth, that changes the bar a little. The same way a telescope seeing an atmosphere around a planet around a distant star, if it had methane, would have. So now what we've done is we've sharpened the focus on Mars as a good place to ask, are we alone?
Now, scientists can't yet confirm that it's living creatures emitting this methane, because the gas can also be produced geologically, either by volcanic activity, or there's another process called serpentinization. We'll talk more about those later. And the jury's still out as to which scenario is more likely.
The issue right now that we're actively considering is whether the methane that we have detected on Mars is a product of biology or a product of geochemistry. Right now, we think it rather favors a biological origin.
Of course, if it's biology, that is huge news. But even if it's geology, that's a pretty big deal too.
Either case, it's telling us that this is not a dead, cold, dried up planet. It's active, something's happening. It's got a pulse, maybe a weak pulse, but it's got a pulse. We're talking about the first discovery of another type of life. That's going to be important in a broad sense of medicine and biochemistry and agriculture, and everything we know about biochemistry will be expanded. And it'll also be a profound philosophical understanding of life in the universe.
So how did we get here? Not long ago, Mars was written off as dead, bereft of life, zip, nada, stick a fork in it, it was done. A cold, hard, dusty wasteland. But now, whether the methane turns out to be biological or geochemical in nature, Mars is very much alive. It's deja vu all over again as scientists learn once more that just when we think we understand the red planet, we find out something new that changes everything.
Each time we've taken a new generation of instruments to Mars so that we could see finer detail than we could see before, we found out that what we thought Mars was not the way Mars is.
In a way, we've been going to Mars for decades now, even if a human hasn't yet set foot on the place. The first flyby was made by Mariner 4 in the dark ages of space travel, 1965.
21 pictures were transmitted by Mariner 4, and they raised much of the veil of secrecy that shrouds outer space.
The first orbiter and lander, Viking mission, was launched in 1975. It sent back pictures of what looked like polar ice caps and dried up riverbeds, but no one could really be sure. Beginning in the mid-1990s, the images captured by newer telescopes and orbiters got better. But the biggest advance came with a ground operation. NASA bounced a couple of robot rovers onto the Martian surface. First Spirit in 2003, and then Opportunity in 2004. Spirit and Opportunity added something new, the ability to move and see new areas. We held our breath as the robots opened their mechanical eyes and gave us entirely new perspectives on the red planet. It was a view like no other, a 360-degree panorama of the Martian surface. And suddenly, Mars came into focus, a rusty, rocky landscape, pitted with massive craters and buttressed by mountain ranges taller than anything on Earth. The two rovers were sent to find out if conditions in this seemingly barren wasteland ever could have supported life. They prodded, they poked and drilled and analysed Mars rocks, searching for evidence of liquid water, the key ingredient for life here on Earth. Rover Opportunity struck pay dirt first, essentially making what amounted to an interplanetary hole-in-one. It landed inside a small depression dubbed Eagle Crater, close to a thin outcrop of rocks. On March 2nd, 2004, NASA scientists broke news that shocked the world.
We have concluded that the rocks here were once soaked in liquid water. So it's the kind of place that would have been suitable for life. Now, that doesn't mean life was there. We don't know that. But this was a habitable place on Mars at one point in time.
And so that opens up this window of possibility that maybe there was life early on Mars and it's still there, deep underground.
Was Mars alive? When was it alive? What is that real dynamic Mars that we now see? How will it inform us about Earth?
Until the rover's discovery, scientists had been divided on whether there was water on Mars or not.
One camp in the Martian community suggested that water was a dominant force, and if you have water, you have life. But there was another controversial opinion that suggested that these features were in fact formed by liquid CO2. What was needed was a close-up ground observations, evidence for liquid water, and that's what the rover missions provided. Then the argument became stronger that, in fact, the mineralogy was being formed by liquid water. So that was a big boost for the water camp, and the liquid CO2 camp sort of disappeared at that point.
So now that Mars was shown to have once been wet, could life have arisen there like it did on its closest neighbour, Earth? And if so, had the life died out, or was it just hiding where we couldn't see it? Was there still liquid water somewhere on the planet? NASA's mantra became follow the water, and that was the guiding philosophy for their next large-scale Mars mission, the Mars Reconnaissance Orbiter, or MRO. The announcement of methane plumes on Mars has brought scientists to the brink of saying that, yes, there is life on Mars. But getting to this point meant putting together the pieces of an enormous puzzle. After those two little rovers confirmed that water had once flowed across the Martian surface, some big questions were raised. Could the ancient Martian oceans have supported living creatures? Could there still be pockets of water on or under the Martian surface where life could still exist? To try to find out, in 2006, NASA sent up a whole collection of instruments on the Mars Reconnaissance Orbiter. The MRO, as it's known, was fitted out with loads of extremely high-tech cosmic spyware, all focused on uncovering the history of water on Mars.
The way we do that is by looking at the shape of the surface, its morphology, how the layering is, the composition of the surface, and then we're probing into the subsurface to see what its structure is and whether or not liquid water might be present. At the same time, we're looking at the atmosphere, but we're looking at how water vapor moves in the atmosphere, and that's our common theme, follow the water.
In order to follow the water on Mars, the MRO has been fitted out with 6 principal sensing instruments.
What we're looking at here is the payload deck. This is our big telescope, the HiRISE instrument. This is a very high-resolution imager. This is the device where we get the best resolution, where we go in and look at the details of what's down on the surface. To see the area around it, we have the context imager. CTX, this instrument has a broader swath, lower resolution. It provides us that regional coverage. This instrument, the Mars Climate Sounder, is looking at how things change in the atmosphere over a full annual cycle in terms of what's the temperature of the atmosphere, what water vapor is there, what dust is blowing around in the atmosphere. Now we have another weather instrument. It's a camera, and it's looking horizon to horizon. This instrument is CRISM. This is our imaging spectrometer, and what we're doing with this is to look at the composition of the surface, because we want to see not only its shape, but what it's made of. On the backside of this spacecraft, we have another instrument, which is SHARAD, the shallow radar, which penetrates into the surface to look for layers of ice.
Here at Lockheed Martin Space Systems in Denver, MRO went from the drawing board to becoming a 2-ton reality. It took 5 years and hundreds of specialized personnel to design the orbiter and construct the instruments for its multi-purpose payload. The finer detail comes from MRO's eye in the sky. HiRISE, or High Resolution Image Science Experiment, is the largest instrument on the orbiter, weighing close to 150 pounds. It's the most powerful camera ever sent into orbit around another planet. Past Mars orbiters were able to identify a spot roughly the size of a dinner table, but from MRO's low-altitude orbit, HiRISE is able to detect an object about the size of a beach ball. One of the instrument's designers, Laszlo Ketsteyer, describes the level of detail HiRISE can achieve.
This rock here is about the size of rock we can reliably see with the camera on the Mars Global Surveyor spacecraft, and it's about 15 feet across, and it's a good-sized boulder. However, with HiRISE, we'll be able to detect the rocks that are about this size here. This is about 3 feet across. Now, one of the nice things about HiRISE is that it's taking these high-resolution pictures in color. We have a lot of science interests on Mars, but one of them in particular is looking at what water's been doing. When especially hot water reacts with rocks, it can change the rock's colors. So here we have a rock that's been altered to a red color with the hot water that's run through it. Hot water can do different things and change rocks to a green color as well. And so with HiRISE, we can see where the rocks have been altered these kinds of different colors and see what the water's been up to. And that should hopefully help direct future missions to the places where the water's been doing the most interesting things on Mars.
The HiRISE camera is photographing key areas of the red planet, but it's focusing its lens on only 1% of the Martian surface. It works in tandem with MRO's context camera, or CTX, which scans broad swaths of the surface at a much lower res than HiRISE, looking for areas that pique scientists' interests. On previous missions, CTX would have been the high-resolution camera.
This was the best resolution that we had.
Richard Zurich illustrates how the two cameras work together using a photo mosaic compiled from previous orbiters.
You had bright areas and dark areas, and we thought we understood what these things are, but when you look at it at greater resolution, suddenly you see what it really is. The dark spots are sand dunes, for instance. But the context imager is meant to get this over an extended area.
Once CTX identifies a target, HiRISE zooms in for a closer look. Up until now, you could only get this level of image detail from rovers, and they could only cover a tiny part of the Martian surface. The camera systems orbiting on the MRO can now generate high-quality images of virtually any point on the planet. But high-resolution cameras aren't the only tools in MRO's water-seeking arsenal. The Compact Reconnaissance Imaging Spectrometer, or CRISM, analyses light reflected from the Martian surface. Its sensors can literally see the individual colour components of light across the full spectrum, from visible to infrared. Since every mineral reflects a unique colour signature, CRISM is able to map the exact composition of the Martian crust. The spectrometer collects data in patches the size of a house to help scientists zero in on other rocks that have been soaked in liquid water and maybe even spot hidden hydrothermal deposits. And the Mars Reconnaissance Orbiter also functions as a weather satellite, letting us see for the first time in detail the forbidding weather patterns on Mars.
Our first emphasis is 1 Mars year of scientific observations. Why a Mars year? Because you get to see all the seasons, and that's an important climate signal that we're trying to capture. In fact, if there's one thing that we want to learn, it's how has climate of Mars changed over time?
The orbiter's Mars Colour Imager, or MARCI, acts as the spacecraft's meteorologist. This camera provides daily weather maps for the entire planet, just like satellites here on Earth, and it tracks environmental changes on the surface.
It's looking horizon to horizon so that you get an orange peel along each of 13 orbits a day, and when you put that together, you've got a global map daily of the weather on the planet, and then we monitor that for a full Mars year.
Keeping an eye on Mars's weather will help keep future missions to Mars safe and also help point them to potentially rich sources of liquid water. But perhaps the most powerful tool on the Mars Reconnaissance Orbiter is one that lets scientists peek underneath the planet's surface. Aboard the Reconnaissance Orbiter is a powerful new instrument called the Shallow Subsurface Radar, or SHARAD. It essentially gives Mars an MRI, allowing scientists to scan layer upon layer far beneath the planet's skin in search of water and ice that may still be stuck in the rocks below.
So far, we've been scratching the surface a few centimeters or probing only even microns. What your eye sees is just the veneer, just the surface of that. And now we want to get into that, but it's wide open as to what we're going to find.
The SHARAD instrument bounces radio waves up to a half-mile into the planet's rusty crust. Once analysed, the reflected waves can detect ice or liquid water in subsurface layers. Over the course of its first 2 years in space, the Mars Reconnaissance Orbiter has produced tens of thousands of images, maps and surveys above and below ground. More information than all previous Mars missions combined. Taken as a whole, the data tells a complex story of climate change and a history of watery environments that existed over the course of hundreds of millions of years. Some of them were just the kind of environments that could possibly sustain life. With data from the Mars Reconnaissance Orbiter, researchers were able to zero in on the very best spot to look for evidence of life-sustaining water. But could they design a spacecraft that could make a pinpoint landing and dig beneath the surface of Mars? Welcome back to Life on Mars. This is a Brink special report. Before the recent announcement of methane gas on the red planet, NASA's mantra in the search for life had been follow the water. Convinced that water ice lay just below the surface of Mars, NASA scientists desperately wanted to examine an actual sample. Well, easier said than done. That would turn out to be one of their most difficult missions. August 4th, 2007, a rocket and its precious cargo, the Phoenix Mars lander, left Earth on a mission to Mars.
We're standing by for completion of turn to entry.
The tragedy of the Mars Polar Lander, which crashed 8 years earlier, had set the stage for this new mission. Team leader Peter Smith was determined that Phoenix would succeed where the earlier mission had failed.
We lost our chance with Polar Lander, and now we've got another chance. Phoenix is coming back from the ashes.
Phoenix, a robot geologist, was equipped to dig beneath the surface, analyse the ice and soil, and search for evidence of life. Only a goal as important as this could justify the enormity of this endeavour.
Landing on Mars is so risky. You really need a payoff to balance that risk.
The biggest risk would be as Phoenix approached Mars in May of 2008. It's called 7 minutes of terror. It's when Phoenix decelerates from nearly 13,000 miles an hour to a soft touchdown on Mars. It'd be up to the Jet Propulsion Laboratory's chief engineer, Gentry Lee, to ensure a successful landing.
From the very beginning, everyone associated with Phoenix has realized that this is a crapshoot. So what we have had to do is meticulously go through and list all the bad things that can happen, and one by one, try to hammer them down to naught.
Phoenix must land using outdated pulse mode thrusters.
We took what we had, we took what was left over, and we tested it and tested it again. And now we believe we've done all the tests necessary. They should do the job.
Finally, on August 4th, 2007, Phoenix took off without a hitch. For everyone involved, the mission was already a dream come true.
This spacecraft is doing what I always wanted to do when I was a child, and that is fly to Mars.
But the ultimate test was in landing. After 10 months in space, Phoenix was just hours away from its encounter with Mars.
Imagine working on this job for 4 years, and now, today, in 3 hours, you're going to find out whether or not you did it all right.
Everyone prepared for the moment of truth.
Atmospheric entry on my mark. 5, 4, 3, 2, 1. Parachute detected. Radar reliable. Constant launch state detected. Altitude 20 meters. 50 meters. Standing back for touchdown. Touchdown signal detected.
Everything went off without a hitch. It was, I don't think it could have gone better.
Yeah.
Tell us your goal for the Phoenix now.
Get some pictures back. We want to see Mars.
The Phoenix touched down on May 25th above the planet's Arctic Circle. It was a perfect landing.
We were very pleased to see that we landed right on top of water ice, and the thrusters spread the soil away and revealed ice right underneath our lander. This was unexpected.
Its robotic arm, more than 7 feet long, dug trenches into the soil. There it found traces of substances that only form in the presence of water.
We know that we have calcium carbonate, which on the Earth would typically be in the form of limestone, and we have clay. These are indicators of a liquid water past.
It was one more step in the search for life on Mars.
Well, I think we're approaching that hypothesis. We understand, though, that Mars has many surprises for us, and we have not finished our investigation.
After operating for more than 5 months, the Phoenix Mars lander had sent back 25,000 photographs, ranging from panoramic vistas to near atomic level images. It monitored weather conditions and even detected falling snow. It took and analysed many samples of the Martian surface, documenting a mildly alkaline soil that could even support vegetable life if the planet were warmer. After the last major experiment analysing soil samples, a storm hit, and in November 2008, the Phoenix lander was silenced. Well, we haven't brought back any Mars rocks to Earth, and neither the rovers nor the Phoenix probes found any direct evidence of life there. But something's producing all that methane, and if it is life, what would it look like? Well, one way to get an idea is to look at what kind of life forms exist in equally inhospitable environments right here on Earth. So I sat down with a scientist who spends his life doing just that, searching for living organisms deep beneath the Earth's crust in places like South Africa and the Arctic.
In the crust of the Earth, if you drill down deep enough, you can find some organisms that appear to be living in the rocks at depth. They don't even, require anything from the surface.
And previously we had always assumed that all living organisms required sunlight, I guess.
Exactly. And so it was obvious. I mean, it was blatantly obvious to us at that point that if you have life existing miles beneath the crust of the Earth, on Mars, you could still have life existing well beneath the crust. The first couple of kilometers on Mars around the entire surface, the rocks are completely saturated with ice. I mean, it's frozen. And as you go deeper down, you get below this icy layer, which we could call the cryosphere. You would have liquid water and organisms like the ones that we have found here on Earth, producing gases like methane, for example.
The kinds of microbes that live on rocks beneath the Earth's crust are tiny, many of them less than a micron in length. But they often form dense colonies, and they have a signature. They give off methane, and also often consume it.
As one organism respires its waste product, another organism is consuming that waste product. And so you can get, even though the organisms themselves are very, very simple looking and tiny, they develop some fairly complicated, larger scale structures.
The Antarctic, with its extreme cold, is another place scientists look for life that's found a way to survive in a harsh environment. Here they've found liquid lakes under the thick ice, harboring millions of microbes. Their origin dates back to the beginnings of life on our planet.
So here we have a piece of ice from ice-covered lake in Antarctica.
NASA's Chris McKay has made 25 research trips to these frozen shores.
Here in an environment where the temperature is well below freezing, and yet underneath thick ice covers we find deep lakes. And at the bottom of some of these deep lakes, we find methane-producing bacteria. So the connection to Mars for us is very interesting. What kind of organisms are making that methane? And could these ice-covered lakes in Antarctica be models for what existed on Mars early in Mars history? And if there's life on Mars today, are they relics of the communities that were more widespread when Mars may have had lakes?
If life exists on Mars, it might turn out to be related to life on Earth, or it might not.
All life on Earth is the same, biochemically. If we go to Mars and find a different type of life, a different DNA, or maybe no DNA at all, different proteins, maybe no proteins at all, by comparing those two types of life, we might learn things about life as a phenomenon that we would never learn by just studying one example. And all of a sudden we would see two books of life, and now we'd be able to cross-reference it. And maybe that would help us solve some fundamental problems in biology that have proven very hard to solve, like the origin of life itself.
It's hard to decide which would be the more exciting prospect, life like our own, or a completely alien life form.
If it's different, I think that would change everything. Philosophically, scientifically, even about who we are. It would really tell us we're not alone. And if it works on Mars, a little dirty ball of dust, you know, a stone throw in the universe away from us, my God, where else could it be?
It's exciting stuff. There's a lot to look forward to. We're going to delve into a deeper look at the methane plumes on Mars when we return with this Brink special report, Life on Mars. Well, the search for life on Mars has been a series of missions, and each one has added some credence to the possibility that we may have company in the solar system. And now, after a decade and a half of amazing discoveries, comes perhaps the most dramatic news yet. There's something underneath the surface of Mars that's generating huge plumes of methane gas. To help us understand what the methane means, I'm joined by Dr. Lisa Pratt, a professor of geological sciences at Indiana University. Now, Dr. Pratt, you are a geologist, so before we all get too carried away about this being life, can you explain to me what are the possible geological origins of this methane?
The most common way that that occurs is in a reaction called serpentinization, named for the suite of rocks that are formed by that reaction. Now that requires exposing carbon dioxide, usually dissolved in water, to the kind of rocks that on Earth are only found in the mantle, and so are only rarely exposed to water near the surface. The places where we see it occurring on Earth are primarily in places where deep fractures and fissures have uplifted rocks from the interior and exposed them primarily on the seafloors where we see this reaction on Earth.
And so why is it that so many people seem to believe that there is a biological explanation for the methane that's on Mars as opposed to these geological explanations?
Well, actually, I think the jury's still out. Either process is an equally good explanation because the methane is really very difficult to distinguish. Rather, it's forming biologically or geologically.
And how do we know that it's an active emission? Do we know that, or do we know that it's just been hanging around for a while?
Well, I think that's based on a number of assumptions. It seems that unless the process was ongoing, we would have long ago depleted most of that stored methane. So again, we're waiting for the scientists that have made this discovery to release additional information to tell us whether or not these releases are truly seasonal.
Would you say that in my lifetime we'll know with a reasonable amount of certainty that there is life on Mars?
Yes, I would think so, because although it's interesting to speculate about whether or not the source of the methane is biological or geological, it really doesn't matter in the sense that once you have methane, it's an extraordinary resource for organisms to consume. So the presence of the methane, regardless of its source, gives us a bullseye in terms of future exploration. We now know where to go and explore to see if there are life forms consuming that methane. And there really is no absolute definitive way to know until you recover a sample and can look at the active process and determine whether or not it's just abiotic chemistry or the chemistry of life.
Incredible stuff. Thanks so much for your time, Dr. Pratt.
Pleasure.
Now, if we're ever really going to figure out these plumes on Mars, some scientists think sooner or later it won't be enough to keep sending up little robots. We're going to need some boots on the ground.
I think it would raise the question, don't we really want to go there? Is our robotic presence enough? Even if science doesn't justify sending humans, wouldn't it be worth the trip? These are the questions. I'm not giving the answer. That's for people and the public to choose if they like that.
But it's not an easy choice. Getting human beings to Mars will be enormously challenging and expensive. Keeping them alive up there will be no small feat. Mars is an extremely inhospitable place. Winds can reach 80 miles per hour. Dust storms can flare up and cloak the entire globe from the sun for months. The atmosphere, over 95% carbon dioxide, can't retain solar heat. The frigid temperatures at the surface can go as low as minus 195 degrees Fahrenheit. Using instruments like MRO, scientists are trying to understand exactly what they'll be up against.
Someday, humans will move about the surface and live and operate, and one of the things that one will want to do is to be able to forecast changes that might adversely affect the way in which they work or even their health. And on Mars, that change is the rapid development of dust storms. And those dust storms can effectively reduce the sunlight on the surface. Certain kinds of vehicles that operate with solar energy aren't as efficient. It can make difficulty in seeing long distances. There's a lot of things you want to worry about.
And then there's the question of how we get there.
When we go to Mars, we are constrained by the position of the planets around the sun.
Though Mars is our nearest neighbour, it's still very far away. At their closest, the Earth and Mars are over 34 million miles from one another. And since the two planets move in different orbits at different speeds, they're usually even further apart. A manned voyage to Mars will have to be timed just right.
The window of opportunity to go from Earth to Mars or Mars to Earth opens up only once every 2 years. So a trip to Mars might involve taking 6 months to get there and then staying on Mars for 2 years. Part of preparing to send humans to Mars is to test out our equipment and procedures here on Earth.
Planning a trip to Mars involves living the life of a Martian right here on Earth. That's exactly what the Mars Society is doing.
The Mars Society is an international organization of people committed to furthering the exploration and ultimately settlement of Mars. We have simulated human Mars exploration stations in the Canadian high Arctic and in the American desert, where we can actually practice Mars missions and see what might work and what won't. The Mars Society has now run about 70 different crews between the Arctic and the desert station.
Through NASA's educational activities, we've been working with the Mars Society to encourage this sort of astronaut training.
I'm going to be in this position here. I'm going to be the geologist, and I'll be scouting for samples.
One of the most important things we do here is our EVAs, our extravehicular activities. When we go out for an EVA, we have to put on our spacesuits, depressurize in the airlock for 1 minute, and then go out and conduct our EVA. The airlock is important because we need to depressurize down to the pressure of the Martian atmosphere so that when we open the hatch, it doesn't explosively decompress.
Protection from the elements and the atmosphere is one thing.
Thanks, Patrick.
But if explorers are to spend months on Mars, they're also going to need to eat. Fortunately, as the Phoenix mission showed us, Martian soil could sustain life if you heated it up.
One of my interests is this notion that Mars could be made habitable once again. The metaphor I use is doing CPR on someone that's fallen over dead. Well, if that person has fallen over, but you can still detect a faint level of activity, a faint pulse, then you're certainly going to be more encouraged at the prospects of being able to revive them. Because Mars is so far away, we don't want to have to carry food with us. We'd like to be able to grow it there.
So we grow it using the Martian resources, the Martian Earth, the Martian atmosphere, which is almost totally carbon dioxide and nitrogen. Humans will die in the Martian air, but plants will live off the Martian air.
It may sound way out there, but some scientists are even talking about transforming the entire climate of Mars to make it hospitable for humans, heating it up using greenhouse gases. It's a process they call terraforming.
The basis of terraforming is the notion that early in Mars history it had life and it's recently dead. Recently for Mars means a couple billion years. We humans have learned how to warm up planets. We're doing it on Earth with super greenhouse gases.
Ironically, to possibly revive some form of life on Mars, we'd need to introduce the same conditions that are threatening life here on Earth.
If we establish human societies on Mars with significant industrial capacity, they could create these greenhouse gases there, warm the planet. It would cause the water that's frozen into the soil to start melting out, running again in the streams and riverbeds of Mars, filling the lakes and putting water vapor into the atmosphere, and water vapor is a greenhouse gas.
Mars will be the first test of what are our intentions as a species as we move out beyond the Earth. And so I think we need to ask the question, can humans survive on Mars? What are we going to do there? And where are we going to go from there? And maybe that's a question we're not going to answer soon, but I think we have to start working in that direction.
A manned mission to Mars may be some time off, but for now, the discovery of methane is forcing scientists to rethink the next generation of unmanned Mars observers, landers, and rovers. Coming up, we'll find out what the next steps are in the ongoing hunt for life on Mars. Life on Mars? Well, we don't know for sure, but the scientific community is abuzz with the possibility following the discovery of methane on the planet. And among the many questions NASA's announcement raises is, what do we do now?
We need a way to identify where all of the active vents are, to quantify their principal gases, to identify which might be dominated by biology, if so, which might be dominated by geochemistry.
And I think given the lack of really compelling evidence for deep active fracturing and faulting to keep water-rock reactions going, it's time, it's prudent that we begin to explore Mars, looking for the possibility of a life form that's exhaling methane.
That may change the plans for the next vehicle poised to explore the Red Planet, the Mars Science Laboratory, or MSL.
We will be launching to Mars in 2011. It is the ultimate mobile laboratory that you wished you had in your chemistry lab in high school.
It combines the concept of a remote automated field lab with the roving capability of its robotic cousins already at work on the planet, Spirit and Opportunity.
What we're doing on the Mars Science Laboratory is we're changing the focus of the science investigation. Whereas Spirit and Opportunity were there primarily to look for evidence of water, which they found, which was great. Mars Science Laboratory is going there to look for evidence of organic matter.
MSL will carry a rich array of a dozen instruments, one of which is an instrument that can actually measure methane in the local Mars atmosphere.
The lab will be powered by a miniature nuclear reactor, which will let it carry more and travel further than any previous rover. But the additional weight of its powertrain and onboard lab will make it much harder to land safely. Spirit and Opportunity used the same basic airbag landing technique developed for the 1997 Mars Pathfinder mission, but the heavy rovers came extremely close to maxing out the system. To get MSL to the surface, engineers have come up with an entirely different approach. This animation depicts the novel sky crane landing.
Instead of putting the rover on top of the landing platform and landing it, we actually turn things around, where we put the propulsion system, the rockets, on kind of like a jetpack on the back of the rover. And when we come off of the parachute, the rockets in this backpack slow us down. They bring us from about 1 kilometer up in the air down to about 20, 30 meters off the surface of Mars. At that point, as we're still coming down, we lower the rover on these cables. And now we've got this rover with its mobility deployed, basically ready to drive, hanging from ropes off of this rocket platform. And we just continue our descent until the rover touches the ground. The computer on board senses that landing, cuts the ropes, and there you have the rover sitting on the surface, and all we have to do is pop up our antennas and our cameras and drive away.
We're not quite on our way yet. MSL was originally scheduled to launch in fall 2009, but NASA pushed that date back to fall 2011. In a way, that's actually kind of lucky, because with the confirmation of methane on Mars, it gives NASA time to reevaluate the MSL mission, including where it should land.
We have 2 years now with a delay in the launch for that decision to be made. And by then we'll have new data in hand. We hope this will sway the project to consider seriously landing at the event we've identified this week, Neely Foci.
The landing site, which is defined by multiple scientists, they've been selecting sites, and one of them is Neely Foci, the region where we see more methane. It's one of the most interesting places on the planet. And it has been ruled out because of the complexity of the landing. But the beauty now is that we have to rethink about it, because that may be a good place to go and look for activity.
The whole point of the Mars Science Lab is to land it at the most compelling place we would dare land a laboratory, an observatory, if you will, on wheels.
The missions that are going to be in the future, MSL, Mars Science Laboratory, and the next orbiter called Maven, those missions could be adjusted now. They're still being produced, still being built. They could be adjusted to directly measure methane.
The Maven mission to Mars is currently set for 2013.
Maven is a mission to understand the long-range history of the Mars atmosphere and provide the context.
It's possible that the Maven probe could answer the question, is methane on Mars biological or geological in origin? But that's in the future. Today, scientists are energized by the endless possibilities of methane's presence on the red planet.
There's an energy source for life. That's very exciting, both in terms of the fact that it's active and the fact that it indicates that there could be habitable conditions.
It's very exciting, and it raises the prospect for life very measurably.
One thing is for certain, the planet is active, and it's active right now.
Do I know whether there's life on Mars? No, I can only be hopeful. But I can say this, with all this new evidence, the prospects, the probability of there being something have gone up. And that's what's important. The trend is up, not down. What an exciting time for Mars.
What an exciting time for Mars, indeed. We don't know what other secrets the red planet will reveal in the future, but we do know, whatever they are, we will cover them. So be sure to join us for Brink every week and online at sciencechannel.com/Brink. I'm Josh Zepps. Catch you next time.